Welcome all of you. Welcome to another video of Maths Made Easy. Now today, since I'm taking up 7 standard topics now, you know that I've been taking 7 standard topics for a while now. So today I shall be taking up the 7th standard topic, ratio and proportion. So this is the first video where I'm going to take up only ratio questions, and then there will be another video which will be taking up only proportion questions. So ratio and proportion will be explained in detail in these two videos. Now there is something along with ratio and proportion, that is speed, distance and time, okay, which is also a 7th standard topic. Speed, distance and time, how a train covers a particular distance at a particular speed and all that, and those sums I have already finished those sums in a separate video earlier. So you might not find so now I shall be covering only ratio and proportion. As I said, the link for speed, distance and time I shall be putting in the description box. You can watch. Okay, so let's start. Now what exactly is a ratio? Okay, ratio is basically a comparison between two things. So supposing you want to make a cake, then it is, I say, 2 cups of flour, 1 cup of sugar and maybe 1 cup of butter. Okay, if you have this 2 cups of flour, 1 cup of sugar and 1 cup of butter, that makes 1 cake. Okay, now if you want to make a very small cake, you take small cups, but remember one thing, whichever cup size you use for the flour, same cup size has to be used here and same cup size has to be used here. It only means that for every 2 parts of flour, 1 cup of sugar and 1 part of butter has to be used. If you plan to make a very big cake, then you will be taking this as a bigger cup, okay, and the same sized cup, the big cup and the same sized cup. Okay, so supposing, what I mean to say is the unit has to be same in all these cases. So here the cup size acts like the unit. So if I say something is 2 kilometers, then it is 1 kilometer and 1 kilometer, like that, or 2 meters, 1 meter and 1 meter. So the unit has to be the same when a particular things are in a ratio. That is the meaning of ratio. Now supposing there is a rectangle, okay, there is a rectangle, and in this rectangle this is 2 meters and this is 1 meter. So the ratio of the length is to breadth is 2:1. So I can even take this as a 4, then this is a 2. If I take this length as a 6, then this is a 3. But remember one thing, if I take 6 kilometers, then this has to be 3 kilometers. If I take 4 kilometers, then it has to be 2 kilometers, or even centimeters. Okay, I take 2 centimeters, then it is 1 centimeter. Okay, then the ratio of the length is to breadth becomes a 2:1. So this is what ratio means. Okay, so remember, we have to always take the unit same, only then we can get ratio of a particular matter. Now here another thing, I was just writing L is to B is 6:3. Okay, now remember, ratio is also written in the simplest form. Ratio always has to be written in the simplest form. So this has to be, okay, ratio always has to be written in the simplest form. Therefore L by B, okay, you have to reduce this till you reach the simplest form. So L is to B is 2:1. 6:3 is not the ratio. Okay, only 2:1 will be called the ratio. Now simplify the following ratios. 2:3 is to 1 by 15. How do I simplify this? Now this way I can't understand anything. I have to make it into a simple form. First thing, convert it from mixed to improper. So this is 8 by 3, 2 3s are 6, and this is 16 by 15. Okay. So that is 8 by 3 is to 16 by 15. Now 8 by 3 is to 16 by 15 is also not a proper ratio. So what we have to do is, a ratio can also be written like this: 8 by 3 and divided by 16 by 15. In that case we will have into 15 by 16. This is 5 and this is 2. Okay, so that is equal to 5 is to 2. Okay, so the simple form of this, it didn't look like that it will be such a simple ratio, is 5 is to 2. So it was in a fractional form and we got a simple numbers out of it, which is very simple, 5 is to 2. Okay, because we can't do, it's difficult to proceed with maths with this kind of a ratio. Now let me take another one, which is, see, another one is 1 by 3 is to 1 by 6 is to 1 by 8. Okay, now this is also a ratio, but then again this is also not in the simple form. So what we will do is, we will try to get it in the simple form. Now how? The LCM of these three is a 3, 6, 8. Let me find the LCM. It is 1, 2, 8. LCM is 24. What I'll do is I'll multiply each one of them with a 24. Okay, so what I get is 8 here, 1 by 6 into 24. See, I am not multiplying with a random number, I am multiplying with the LCM. So this is a 4 and 1 by 8 into 24, which is a 3. So the ratio now becomes equal to 8 is to 4 is to 3. Okay, note one thing, that 1/3 was the biggest fraction. Okay, you have to keep watching this. 1/3 was the biggest fraction, so we got the biggest ratio here. This was the smallest fraction and we got the smallest ratio here. That is just a quick check from your side. If A is to B is equal to 3 is to 4 and B is to C and B is to C is 6 is to 7. Okay, then find A is to C. Then find A is to C. So this is our new sum. Now the thing is, if you note, in the thing that they are wanting here, B is missing. Okay, so we'll have to find it in a way that we can eliminate B in the process. Now see, another way of writing ratio is this, right? Another way of writing ratios is this. Okay, and B by C is 6 by 7, A by B into B by C is 3 by 4 into 6 by 7, right? It is 3 by 4 into 6 by 7, and that is, now cancel out the B. This is plain algebra. Okay, cancel as much as you can here. So A by C has now come to how much? So after cancellation, what I have got is A by C is 9 by 14. Okay, so my ratio of A is to C is 9 is to 14. Okay, now note one thing, that in ratios, one very important thing is the sequence. Okay, if you write A is to C is 14 is to 9, that is absolutely wrong. You are trying to say for every 14 parts of C, we take 9 parts of A. Okay, so you can't say, you just can't write it the other way around. Ratio goes wrong if you write it like that. Okay, so this is one of the sums where we eliminate one of the variables. Before this we talked about fractions. Here we eliminated one of the components of the ratio. If A is to B is equal to 5 is to 6, 5 is to 6, and B is to C, B is to C is equal to 8 is to 9. Okay, B is to C is 8 is to 9. Find A is to B is to C. Okay, so if A is to B is 5 is to 6, B is to C is 8 is to 9, find A is to B is to C. Now how do we get it? Now here what do we see? All the three variables are included, right? All the three variables are included. So A by B is 5 by 6, B by C is 8 by 9. Now how do we bring them all in the same, all together? Okay, there has to be some point of equality where we can compare. So now if I take the LCM of this, the two values of B, one is 6 and one is 8, the LCM of 6 and 8 is going to be a 24. Okay, so what I'll try to make in both these ratios, in both of these, I'll try to make the B is equal to 24. How can I do it? A by B is 5 by 6 into 4, that makes it a 24. But then since it is a fraction, I have to multiply here also, that is 20 by 24. Okay, B by C again 8 by 9 here into 3, that makes it a 24 into 3. So whatever I multiply here, I have to multiply it both in the numerator and the denominator, that makes it a 27. So I have 20 is to 24. So now note, both the B's have become equal. Okay, so since both of them have become equal, so now I know that 24 cups of this, then 20 cups of this, again 24 cups of this, it is 27 cups of this. Okay, in that case, or 24 meters here, 20 meters here, 24 meters here, 27 meters here. Now I can, since both have become due to or with 24 meters, okay, with the same number, both of them A and C are being compared to the same number, then we can write the final A is to B is to C, which is 20 is to 24 is to 27. We can write it like that. So in order to bring them all together, we have to make this common value, you can see the common value here, we have to make the common value equal, and then we can proceed. Now here is one very interesting question. If 3A is equal to, now this is also a ratio question, 5B is equal to 6C, 3A, 5B, 6C. Okay, then find A is to B is to C. Okay, so they want the ratio between A is to B is to C. Now how to tackle this? So what we will do is 3A is equal to 5B is equal to 6C is equal to K. Okay, so now A is equal to K by 3, B is equal to K by 5, and C is equal to K by 6, isn't it? So we have got A, B and C, everything in terms of K. Okay, now what we'll do? We shall be finding a LCM of 3, 5 and 6. LCM of 3, 5 and 6, you can find it out. It is going to come to a 30. So we'll multiply with that. So basically A is to B is to C is now 1 by 3 is to 1 by 5 is to 1 by 6. Now this has become the first type of fraction type of sum now. Now we multiply with a 30 each one to get it in a simple form. So 1 by 3 into 30 gives me a 10. 1 by 5 into 30 gives me a 6. Okay, and this is 10. 1 by 6 into 30 gives me a 5. Okay, so now I have all three of these. Now I have, note, A is to B is to C. 1 by 3 is equal to now is 10 is to, this is 6 is to 10 is to 6 is to 5 is my answer. Okay, 10 is to 6 is to 5 is the wanted ratio. Now here is a question, certain sum of money has been divided into two parts in the ratio 5 is to 8. If the first part is rupees 250, then find the total amount. Now they have told you the first part is rupees 250. Now what we will do is, let the common multiple be x. Okay, let the common multiple be x. Now where is the question of common multiple coming from? Okay, now remember the two monies was, 250 and something else. Okay, and they were in the ratio 5 is to 8. Now if it is 250 and let's say p, that is the other part, and they came in the ratio 5 is to 8. Now these are very simple numbers which do not cancel any further. They can't be reduced any further. That's why they are being called ratios. That is, when I have cancelled this and this, it has come to 5 is to 8. Okay, now that means 5 into something will give me the 250. Okay, that is what I have cancelled out. Okay, 8 into also something. Okay, and that is the same multiple. Okay, whatever you have, that is 5 here has been multiplied with, let's say, I think it's a 50 to give me this. Then we have reduced 50 from the denominator also, because when we reduce from both, right? If it is a 15 by 20, then we reduce with a 5. So 5 3s are 5 4s are. That is how we do. So we must have divided the number that was here with the same number as we have divided this with. Okay, in order to get 5 is to 8. Now to get back this number, I am saying I am multiplying back with that number that I had reduced. That is what makes me get the common multiple. So remember, when we multiply with x and x, we are, till now this is 5 is to 8 is a ratio, it is not the number. This is where a very big point of confusion. Okay, but when I multiply with 5x and I make it 8x, this is my algebraic form of the number. It is no longer the ratio, because I have given back the common multiple. Okay, so now here, after giving the common multiple 5x plus 8x, yeah, okay, 5x and 8x is equal to the total amount. But then I don't know the total amount, but I do know something, that is 5x is equal to 250, x is equal to then 250 by 5, which is 50. Okay, so I know this, that x is equal to 50. I have come to know x is 50. Now I multiply the same 50 here. 8x is equal to how much? 8x is equal to 8 into 50, which is a 400. Okay, how am I doing it without rough work? I am just multiplying 8 into 5, writing 40 and then putting this. That's the way you should do your calculations. Okay, so this is here, it is a 400. So now they have asked for the total amount. Let me find the total amount. The total amount is going to be a 400, which is this, plus a 250, that is a rupees 650. Okay, that is my final answer. Now here is a question, rupees 645 is has to be divided into 3 parts, but there is some condition. 2/5 of the second part. Okay, first part is 2/5 of the second part, and the ratio between the second and third part is given as a 4 is to 3. Okay, so what we have to do is, now let me convert this to numbers. So if the common multiple, let the common multiple for the last two ratios be x. Okay, if the common multiple is x, the numbers are 4x and 3x. Now I can't put the ratio sign anymore. Okay, the numbers are 4x and 3x. Now the first part is 2/5 of the second part. Now this is the second part. Okay, so first part is equal to 2 by 5 into 2 by 5 into of the 2/5 of the second part, which is 8x by 5. Everything is algebraic only. Okay, as of now I don't have any numbers. Okay, the total number is 645 and the ratio between the third and second and third is 4:3. Now I'll have to form one simple linear equation because everything I've got in terms of x now. So my simple linear equation is now going to be 8x by 5 plus 4x plus 3x, which is equal to 645, right? So that is the simple linear equation that I am forming. Okay, now how to solve this simple linear equation? Now here in this linear equation the LCM is a 5. So I'll take LCM as a 5, then it is 8x plus, I'm just doing one fraction addition, okay, plus 15x, that comes to a 645. So this is 28 plus 15. Okay, 28 plus 15, that gives it a 43. Yes, so 28 plus 15, that is a 43. 43x by 5. Okay, 43x by 5 is equal to 645. Now how do I proceed with the sum? Now we have to find the value of x. If we find the value of x, we can find all the three parts. Basically we are supposed to find all the three parts. So 43x is 645 into 5. So x is 645 into 5 by 43. Okay, x is 645 into 5 by 43. Now here I have a feeling that it might go. Okay, so I will try with a, let me try with a 15. Why? Because I'm seeing a 3 here and I can see a 5 here, and otherwise there's a prime number I cannot cancel. So 43 into 15, 15, 1, 2, 1, 43, 5, 4, 645, correct. So this way you have to guess little bit. I saw the 5 here, I saw the 3 here, so I thought if I multiply with something with 5 I might reach this number. Okay, and otherwise this was a prime number, so I was not getting any method to cancel this also. Now my answer, x is a 75. So if x is a 75, the first number, which was 8x by 5, is now the first part is going to be 8 into 75 by 5. Please don't multiply. Please don't multiply and land up in trouble. So the first number is a 120. Okay. So this is rupees 120. The second number was a 4x. So 4 into 75. Okay. 75 into 2 is a 150. So 4 will be a 300. So that is a rupees 300. And the third part is 4:3, right? It was a 4:3. So the third part is a 3 into 75, which is a 75 are 225 rupees. So how do you know whether you are correct or not? You can actually add these. Okay, this should be your method to check in the exam. 120 plus 300 plus 225, that should give you, see, I'm getting 645. So this much checking also you should do in the exam, so that you know then and there. So if you have got your 645, actually you don't have to go through the whole sum to check it or to revise it. Okay, that is enough to tell you that your sum has got absolutely correct. Another thing, don't forget the units in these sums. Okay, the present age of Rahul and Diya are in the ratio 4:3. 6 years hence their ages will be in the ratio 6:5. Find their present ages. Okay, present ages are in the ratio 4:3. Okay, now what do we do? Again we'll take a common multiple, x. Okay, so present ages are, you must write this line, common multiple be x. Then present age of Rahul is 4x and present age of Diya is 3x. Okay, and 6 years hence, now the word hence means afterwards, their ages will be in the ratio 6:5. Okay, so after 6 years Rahul's age will be 4x plus 6. Okay, and the other one, which is Diya's age, will be 3x plus 6. Okay, 6 years hence 4x plus 6, 3x plus 6, that is going to be 4x plus 6, 3x plus 6, and now the ratios become 6:5. Okay, so this is my linear equation. Now in 7th standard only they start with linear equation. In ratio chapters it becomes all the more important. You can go through my videos in linear equation. I have about 3 to 4 videos in linear equations. You can go through this. I'll put the link in the description box also. So here, how to find it? Cross multiply. Okay, very simple method of cross multiplication. This is 20x plus 30 is 18x plus 36. Get all the x's to one side. So that makes it 20x minus 18x, that is 36 minus 30. Remember, in linear equation, whenever you bring something to the other side of the equal to sign, it gets a change in sign. Okay, so it has got a change in sign. 2x is equal to 6, x is equal to 6 by 2, which is 3. Okay, this is explained well in my linear equation video. So here this is x is equal to 3. Now what have they asked? They asked for the present ages. Present age of, therefore, present age of Rahul is going to be 4 into 3, that is 4x, which is 4 into 3, which is 12 years. Okay, so that is 12 years. And Diya's present age is 3 into 3. Okay, 3 into 3x, which is 3 into 3, which is 9 years. Okay, so remember, to see the question properly, what have they asked? Have they asked the present age, or have they asked the age after 3 years or after whatever 6 years? So you have to see that clearly first before you start the sum. Okay, so this is your answer, this is your answer, this is 9 years. Okay, so one of them, the second one is 9, the other one is 12. Another thing, be very careful, because since their present ages were in the ratio 4:3, Rahul was bigger, Diya was younger. It is clear. Here also, when you get your answer, go for that, check that, is it Rahul is still bigger and Diya is still smaller or not. You must check that. Okay, so that is it. Then now here is a very commonly asked question: which ratio is greater, this one or this one? Two ratios are given to you. Okay, in other words, it is the same as asking which is a bigger fraction. Now here I want to tell something. I really have to talk to you all for this. Here this sum is done with the method which is used in almost every school, but I do not approve of that rule at all, because that rule, it is the cross multiplication method. Students multiply this, then they multiply this. These two they multiply. If this side they are getting bigger, they say this is bigger. If that side, this 21 into 19 they get bigger, they say that fraction is bigger. Okay, now so children do learn it up, but then they don't understand why, what is happening. The method is correct, it is absolutely okay for MCQs, but then you cannot be using it for regular sums, because it does not explain the method at all. You are definitely going to get your sum correct, but then it cannot be used as a step for a sum, because it does not explain the method at all. Why should you cross multiply? Why should the left side be suddenly bigger fraction, and why should the right side be the smaller one? It explains nothing. Okay, so we'll go for the other method, where we'll go for the LCM method. So here this is one and the other one is this. Okay, the LCM of these two is of 21 and 28. The LCM is, let's say what it is, 21 and 28. Let's take a 7. Okay, so it is 21 into 4, that is at 84. So 84, we'll try to get that 84 in the denominator. So here we got an 84, but if we multiply with the denominator, we have to multiply here also. Okay, so here into 3, that's an 84 into 3, that is a 57. So what happened is we have basically got equivalent fractions for these two fractions. Okay, and so after making equivalent fractions, now we see, yes, this is the bigger one. Okay, so we say 19:28 is greater than 11:21. Okay, so that is the logic behind it. We have to compare after we make equivalent fractions out of this. So next time you get a sum like this, please use this method. This is absolutely correct. There's nothing wrong in using this method. I know that method sometimes is a shortcut. Okay, it is a shortcut. So that is it from the chapter ratio and proportions. From ratios, I shouldn't say it is from the chapter ratio and proportions, but I have taken up only ratios here. So those are the sums that are very important from ratios. So you have seen I have taken up a variety of sums. If you still have any doubts, you can always post in the comment box, and please let me know in your comments if you are finding my videos useful or not. I would love to hear from you. Okay, then that's it for today. If you like the video, do not forget to like, share and subscribe. That's it for today. Thanks all of you. Bye then.